And again, he has been known to make mistakes on the AP questions. So if there is something wrong, just let me know and I'll fix it for next year. Here's what he has. 2 is D. 4 is D. 6 is B. You didn't have to do 8. 10 was C. You did not have to do 12 or 14. 16 is C. 18 is D. Yeah.
Could you do 17?
I'll try my darndest. VR, did you stop and then start?
Mm-hmm.
You're the best.
Thanks.
Okay, so this asks us to find the area, and this is a calculator problem, find the area inside the larger loop, but outside the smaller loop of this guy. So let me get my calculator out and put in 1 plus 2 cosine theta. So I don't know what my window is going to be yet, so I'm going to start 0 to pi. And I'm going to keep it at -3 to 3 and -3 to 3. Do you see why I'm keeping it -3 to 3? Someone might say, well, why would you go -3 to 3 if it's 1 plus 2 cosine? So the maximum you're going to get is 3, but the minimum you're going to get is -1. So why not go from -1 to 3? What's the answer to that? No, it does matter. The R value could be 3 when theta is pi. When theta is pi, I'm over on the negative x-axis, so the x value could be -3. The R value could be -1, but the x value could be -3. Do you all see that? So whatever the greatest value is of R, or smallest of -R, you should have as your upper and lower limits for x's and y's. So I'm going to use -3 to 3 and -3 to 3. So let me graph this. So it starts there, and so I know there's going to be a larger loop and a smaller loop that's inside. So that's what I get there. So I can't really see it yet. So let me go from, and some people here would choose to go from 0 to 2 pi, and then others would choose to go from like -pi to pi. What do you want me to do? 0 to 2 pi or negative pi? What? 0 to 2 pi. So now we're going to start there. It's going to go, it's going to hit there at like 1, and then it's going to come back through and be 0. Then it's going to go back there. Inner loop. Finishes the inner loop. Goes back out to the outer loop, and let's look at those values up there, and it stops. Do you see how the like thinking thing or working thing go, and then it stops right away? So this is something that I want to point out as we from what I just saw. So observations. I saw this. This is what it would really look like. It's something more like that, right? So in terms of my theta values, I saw that right there, this was theta equals 0. This right there is at theta equals pi halves. Do you see that? And then right here, as it's going down this way, what was theta equal to here? Right, we don't know. But then as it went there, right there we had theta equals pi. So this guy, we're like, I wonder what that is. Well, we could figure it out by what is occurring. So really quickly, let me trace this here. What do we know? How could I figure that out based on the polar equation that I have? Set r equal to 0 because it's at the pole, right? So r equals 0 implies 1 plus 2 cosine theta equals 0, or cosine theta equals negative 1/2. So what theta value am I at when cosine of that is equal to negative 1/2? 2 pi over 3. So this is theta equals 2 pi over 3 is when I get there, and then it goes there. And then, let me choose red. I'm gonna, that's theta equals pi again, and then it goes there, and it hits there again. So it's not just theta equals 2 pi over 3, but let me finish it. It's or what? So for cosine theta equaling negative 1/2, on my unit circle, the negative 1/2 is going to be, for the cosine value, up there, and then also down there to be this negative 1/2 value. And so we have that it's 2 pi over 3, or 4 pi over 3. And then each one is plus 2 pi n, right? So this right there is theta equals 4 pi over 3. And then right there, this is going to be, what do you suppose? 3 pi halves. As we're increasing, because my theta values went from 0 to 2 pi, right? So you're correct if you stated negative pi halves. That would have been correct, but I'm talking about on my window for my theta values that I've chosen. So we're going from 0, pi halves, 2 pi thirds, pi. 4 pi thirds, 3 pi halves, 2 pi is going to put us back over here. Okay, so now talk to me. I want everything that's inside this guy, yet outside of that small. It almost looks like the pit of like an apricot or something like that. I know that would be more central, but something like that, right? So outside of this, but inside of that. That's what they're looking for. Inside the large loop, but outside the small one. So what do you think? Okay, so here's, so let me use blue. So first of all, I'm going all the way out. I'm sweeping through. So I'm only going to focus on half. Do you see why I'm only going to focus on half? Because of the symmetry of this whole thing. So really going out to this outer guy, which is, there's only one equation there, it's going from theta equals 0 all the way to theta equals 2 pi over 3. Do you see why I wouldn't go to pi? I would just stop at 2 pi over 3. And do you see how that includes this whole thing, which is what's inside and even what's inside there? But then I would subtract, and what I would do is keep going with these theta values. I would subtract one of those. And it doesn't matter if you subtract the guy that's down here or up there. So what I'm saying is, for what I'm subtracting, I would choose my theta values to go from 2 pi over 3 to pi. If you are saying, no, I want it to go from pi to 2 pi over 3, or from pi to 4 pi over 3, because that's on that where the y values are positive. That's fine. You can subtract that part of that little inner loop. Do y'all see what I'm saying?
Yep.
Yes?
Why is it pi on the smaller loop and not on, like, where the bigger loop is the origin?
Right there, we solved when r is equal to 0. So the distance away from the pole, or the origin, is r. So when r is equal to 0, that means it's at the pole. And that occurs at 2 pi over 3. And we saw, when we just had the window go from theta equals 0 to theta equals pi, that it stopped there. So I know that that's theta equals pi. Or you could plug pi in for theta up there. At pi, right, when theta is equal to pi, plug pi in. You have cosine of pi, which is -1 times 2 is -2 plus 1 is -1. So when you're at theta equals pi, you're at -1, so it goes that way 1. Does that make sense? Ish?
If it's negative, then pi is going that way.
Because theta is pi, which we put over there, so then it goes back from where that is, so it's on the positive x-axis. Because if r is positive and theta is pi, then it's going to be on the negative x-axis. But if theta is pi and r is negative, then it's on the positive x-axis. Yeah?
Is it possible if I could do like from 0 to 2 pi and subtract?
Okay, so let's pause with that question. Let me finish this and then I'll answer that, okay? So, my setup would look something like this. First of all, what I would want is, I want to say that the area is equal to twice, and I'm doing twice because I'm focusing on half of this thing, so I need to double it in order to get the total area that's inside the big loop but outside the small loop, right? So that's where the 2 times comes from. And then let's add up all of the blue highlighter, section or region. So that's going to be, don't forget your 1/2. 1/2 times the integral from 0 to 2 pi over 3 of, we have r 1 plus 2 cosine theta squared d theta. So that's too much. So now we need to subtract the region of the pinky purpley. Is that fuchsia? I don't even know what. Anyway, 1/2 times the integral from 2 pi over 3 to pi of 1 plus 2 cosine theta quantity squared d theta.